is looking like, if I check my plan book, and by the way, if you're ever off in your plan book, I have now decided to just keep a Phoenix plan book also. So just like you guys had your, it means you could copy mine if you get to extensions and you're like, oh crap, what's the homework? You got to make sure you look at the right math class, because remember I have 3 math classes and no other classes.
Wait, so you can write math all at the top?
Yes, because that's what you write in your plan book. Well, I don't know. You might write math in your plan book. You're in math 8. So that you, if you want to be technical, would have math 8 on the top of your plan book. So I have math 7, high school math 2, and math 8. According to my plan book, we're going to do 416 today, 417 tomorrow. You already did. I don't know why people are talking over me. It's very confusing to me. This is why people like think what they do about kids these days, quote unquote kids these days. So that looks like Thursday would be kind of flexible. So it'll probably be Thursday that we get you back the Chapter 3 Mastery, which a lot of you have done really well on. The Mini Mastery, which again most of you have done pretty well on. Not totally done with that one yet, but then we'll go over all of that. Take any other questions off the closure. And then everything else, Chapter 4. Give me eyes so I don't have this question a million times and then get frustrated. All other Chapter 4 homework is due Friday. Okay? So, everything. If you've turned in 3, awesome. If you haven't, that's part of it. And then there's 414, 5, 6, 7. Yeah, it's going to be a lot. And closure. Please stop. This is why I went middle school, not elementary. All right, any questions? All the rest of your homework will be due this Friday. Yes, I could collect it before then, but hey, what's the point? Avi.
I didn't finish the mini mastery.
I'll try to give you more time. I might just grade what you have done, though. That's like, I'm not taking any more class time on that, probably. It's really just a gauge point, like a checkpoint of like, are you ready for the mastery? Sometimes I don't even put them in the grade book. I just give them back to you with feedback, saying like, hey, if this was the mastery, here's what you got to work on. You know what I mean? So don't stress out about that. Don't get yourself worked up or anything. It's all good. Don't trust me. I'm not going to put any grades in the grade book. Like, you wouldn't get a progressing for not being done. And if you do, I'd normally give you more time before then. Yeah, I mean, sometimes that means like, yeah, you don't know it well enough. If you just sit and stare at a test, and then that's why you're not done, like, that's kind of different. But yeah, if you put good effort in, it showed me good stuff. It's all good. Henry.
When did we have the mini mastery? Because I wasn't here last Friday.
Yeah, so I bet you can piece things together. What day do you think the mini mastery was? So that, or I'll just excuse it for you, since you weren't here. So, and I didn't just say that's what is happening. I said that or. So you'll either need to make it up or I'll excuse it. It's the same stuff that will be on the mastery. So long story short, you want to look at the mastery no matter what. You want to make sure you know what was on it. Simon?
Not a conclusion question, but what about like the title of the thing?
Today, we are graphing a line without a table. So you could just put graphing lines or no tables. You could put a little no sign on top of your paper and put tables in it, I guess, if you want. Graphing lines without tables. And this will circle back to what we were doing last week. So your white sheets today, not Orchid, and sorry for your organization. I will warn you right now, you're going to lose your white sheet. Now prove me wrong, right? The worksheet for today, the practice sheet, is white, not Orchid, right? That's bad. And yeah, my bad, but copies aren't back, so I just had to make them here. Otherwise, you would just have to do your homework on graph paper, and that's worse. So please don't lose your Orchid sheet. But those of you who come to me and tell me that you lost it, you're like, yeah, but it was white. It didn't match the other things. I'm telling you right now, attach it to something or make sure it's clipped in. You don't need it right now because there's no class examples on it. So put it away right now if you want to. I will give you 30 seconds to do something with that paper to make it safer than it is right now. You worked ahead and you did it already or what? check off. Jump over that. You completed the thing we're doing in that moment, and we're still waiting on other people. Oh, sure, I guess. Yeah. I guess I now understand what you were actually asking. Alright, so... excuse me. We've got some situations here to analyze. And before we dive into this, what is the form that most of these things go in? So when it says write a rule, you can get back out if you get stuff done. I need you with me right now. When it says write a rule, what's the general, like, what are we looking for there? Henry?
What do you do to X to make it Y?
Yeah, what happens to X to make it Y, and what's the standard form that we're used to for these linear rules? Yeah, Y equals MX plus B. So somewhere on your graph paper, the top would be a great option, right? Y equals MX plus B. And if you need the reminder, like I did when starting out, M is your growth. And another way we can talk about that, and a lot of us probably forgot this, is the delta Y over delta X. And B is our like original point, or our zero figure for the y-intercept, is the technical name we start to call it.
But you said we should memorize those names.
Yeah, so use any one that you want.
Mr. Hudson, for
Yeah.
For the delta y, delta x, would that matter if they were negative or not? Well, it does. Well,
I mean, yeah, it'll make your slope either positive or negative.
Yeah.
So I'm going to go down a ski slope.
Yeah.
I want it to be negative. But if I'm going to hike a mountain, that slope's going to be positive, right? So yeah, kind of it matters. But now, whether I go forwards or backwards up it, doesn't. So I think what Avi's getting at is if I made a triangle, actually let's use a highlighter, make it easier. That went from here to here, and instead of saying +2 +4, I looked at going from this point down to that point. It would be -4 -2. What happens when you do a negative divided by a negative? It's still a positive because this is a positive slope. So this is not a negative slope, but if I went from here down and then over, it would be negative, negative, but it's still describing a positive slope because negative divided by negative is positive.
Is there
So, do you have, like, so if like, the lines have to be clean, how do you find, like, how do you know how it's, like, negative? Because, like, if you can, like, for the four, like, the four.
So I'll tell you, sorry to interrupt, but I'm not going to answer that right now. That's your task right now. Like, that's the first thing I'm going to have you do, is figure out the rules for those, and then we'll scroll down to these. We have 6 rules to try to figure out, and if we can't, that's okay, but that's our start point, right? Of like, oh crap, I don't remember how to figure out those rules. So remember, the M is your growth, the change in Y, or the rise, or the change in X, or the run. And then B is your y-intercept, or your start point, or you hit the y-axis, or whatever.
So we're just finding the rules.
Oh, that's probably hanging up on the wall. There's a painting in my house that we don't really want.
That's what I was talking
It's
about.
nice.
Well,
I
I
have
have
my
my
house.
house. That exactly.
I take it. I buy it.
Nope. I should have on your papers A with an equation y equals something x plus b. B with an equation y equals something x plus b. Push it down. somebody was bothered on the quiz about like on C where that 5 is off to the side. That's just saying that's where we cross the axis.
Can you just go and take a picture of
Not yet. Hey, if anybody else's homework was messed up on the copier hole punching these or something, you don't have to draw the graph on your paper, guys. Make sure your directions were to write the rules for these graphs. Not to draw the graphs, that's going to take us too long. We're just writing the rule. So, we use some random cards to wake us up this fine afternoon. Mr. Shaskis, how can we talk about A?
So, should I come up or not?
You don't need to. I mean, if you can tell us from there. I don't even really need to write anything. Do you need to come up?
Well, not really. So, it's just hard. I looked I looked at the difference between the point of 0x and 1x, and then I marked that as my m for the x because that's how much it's growing.
You went from here to here. You said 0x to 1x?
Yeah, it could be 2x or 3x, though it really doesn't matter. As long as you're just going 1, whatever whatever the y is growing by, whatever the y is growing by or decreasing by is going to be the m. And so then in order to find
So
out
what is our m here?
oh, our m here is 2.
There we go. 2
So
over 1.
then in order to figure out what our b is, we have to look at the point where 0 is, because 0 times x is always going to be 0. So all we would have left is the constant, or the thing we're adding, or b. So our b is 2.
I'm going to move this from there. So, as Simon walked us through, y equals 2x plus 2. Any questions? B did not give us a growth triangle, but we could draw one. Now, I heard a technically there. Was that Alex? Technically what?
Well, I was just saying, technically, you already drew it, so we already need the growth triangle because you already.
Yeah, and we don't have to go all the way up to that point, right? They, like, from dot to dot go 2, but we don't really have to. So if we just use this, what's our equation here? Just shout it out, guys.
2x.
Yeah, 2x plus 3. The only thing that changes is the y-intercept. Crystal, what about the equation for C? Yeah, 8x plus 5, because this growth, 8 over 1, and then the y-intercept of 5, with 8x plus 5. Let's go no talking. I bet you can do these in 1 minute. 1 minute to do all 3 of these. I bet you can do it. I'm absolutely not picking on people, but it was 8th grade when I figured out I needed glasses. If you're starting to realize you can't read the stuff on the screen, you might want to go to the eye doctor. I need to go get my glasses. 30 seconds. You got this? Because we never set goals, we don't know what we can do. Hit the D class. Yeah, well, that happens. It's called the time warp. Maybe like 2 of you got that. I said it's the time warp. All right, Patrick, do you have the equation for D for me? Yeah, -2 comes from this growth triangle, right? -2 and 1. So we could write it like this if we want, or you can just write -2. And then plus 8. So the x is 100% necessary. But the over 1 showing the change in x, dividing by 1 doesn't do anything. But if you want to get yourself in the habit, most slopes are fractions. As we get to the more difficult work, most slopes that we talk about are going to be like 5/13ths, 7/29ths, like awkward fractions. In E, Alina, what is our equation there? Now, how'd you get the growth of, oh, that 10 is not actually that point. That was tricky. So this value then you figured out is? So that's 8. So you're right. Yeah. Well, y equals, so wait, what's the growth triangle that we set up here?
It's 4x.
Ooh, because this is 8 and this is 2. So guys, be careful. This one's scaled differently. Right? It looks like a 2-1. It's not. This is 8. This is 8. This is 2. So the slope here is 8 over 2x plus 8. So y equals 4x plus 8. Please check your E. Y equals 4x plus 8. Because their scale on the y is different than the scale on the x. I know, that tricked me at first too. So be careful, when it's on grid paper, they sometimes just mark the easy numbers. Here, because it's not gridded, they show you exactly where it's at.
Oh, no, I meant
I know. I thought that was 10 also, but be careful, that's on this line.
Yeah, I just put it as 10 because I was like, oh.
Any questions on that? What is the growth here? Anybody? -4, even though it doesn't look right, because the 4 is so much smaller than the 1. -4x, or -4 over 1, plus 12. What questions remain? Yeah,
Is
Liam.
it proper not to scale
It
it?
depends. Often they stretch graphs just to show the most data. So no, a lot of graphs aren't one by one. Like the vertical might be different than the horizontal. Or like the horizontal.
I'm just saying, like for F, there's no other numbers besides 12.
So imagine if the horizontal was like years and the vertical was like money, or two things that they're not the same thing. So then the numbers being different and skewed like that makes sense. So maybe they lost $4 over the course of the first hour they were open or something like that. There was another hand. Yeah. That's a prolific question for people thousands of years ago. I do math because it makes my life better and easier. It stops me from wasting money at the grocery store. Helps me know what things like I can actually do or not do. So now let's reverse it. On your paper, XY axis. Probably flip to the back maybe. Big old XY, well not even big old. It doesn't really need to be big old. A 10 by 10. A medium size old. Or maybe a medium size middle age. You could if you want. That's up to you. Wow, roll your eyes any harder at me. I'm not requiring it, but if you want to, you're supposed to have colored pencils in your pencil pouch. Then do it. I didn't say no. I want you to graph these 4 lines. If you have any... So, when we go to graph lines, guys, our axes should be like this. It should be 4... Hey, can I help with somebody? You are correct. On the front is different than the back. So if you are I want my squares to be the same size, only use front or only use back.
I didn't even notice that.
Yeah, they're 2 different sizes. So I'm partly talking to you, and that's why I stopped, because you were talking to Serena. Our axes should T, right? They should make a 4-quadrant graph, not a 1-quadrant graph. 4-quadrant graph. So your graph needs to show positive and negative for all x and y values. So fix that. Yeah, graph them. You're not waiting for me. Yeah. A 1 by 1 is fine with me if you want. I normally do 1 by 1 unless I have a reason to do something different.
I'm saying as in how many tall, how many long.
Oh, like enough to show the data. A 10 by 10 is probably safe.
This would be right? For the first one? Right.
Well, it's right and up.
It would be left. Are we just like fighting these?
That's not at all what we're doing. So, Katie Ann, I am sure you asked that as a silly question. We are graphing the line made by these equations. So this is your slope. This is your y-intercept. Once you plot the y-intercept and you know the slope, you can really just make a couple points and connect them with a ruler. So if I was going to do this, so Katie Ann, being very silly, graphed it like we were graphing a point. We're graphing many points. She was just goofing around. She's just teasing. So to graph 4x plus 3, first thing I graph is my 3. 1, 2, 3. 3 on the y. Sorry, I'm trying to figure out how to get my dot camera a little... I glued part of it. Hold up. So, sorry, my dot camera is how it is, so just, which actually I guess I can. We can do that and make life easier. Yeah. Yes, I will in a moment, but I'm trying to make sure everybody knows how to do their growth. So, like when I pause Desmos, pause yourself. The slope here was 4, so from here, we go up 4, boom, 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 and over 1, because if I made 4 a fraction, it would be 4 over 1. I can do it again. Boop, 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 over 1. To go the other way, boop, 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 And instead of going right, I go left. Here's a check. 4 is a positive slope. Is my line, when it goes from left to right, rising positively? You betcha. So now I can connect these and label it y equals 4x plus 3. Please make sure you label your lines. I don't care if they're color-coded or not. Label each line. There, Alina, is your view, again, of the rest of them. Yeah. No. Because I have one bottle, and you shouldn't be using pens in class anyways. At max, colored pencils maybe. Well, most colored pencils you can erase. You get the other ones practically.
Get the erasable.
If you are on the back of the fancy paper that has the plastic on the edge, those squares might be kind of small to work with. So feel free to make it like each 2 squares is worth 1, or whatever you want to do to make that happen. So with B, what's the y-intercept for B? There isn't. So what is your y-intercept? 0. There's a plus 0 here.
Wow, that's very convenient and efficient.
I just did that too. I gave you $0. Look at that.
Wow.
I'll double your pay. Give you $0.
You can erase it.
Yeah, I'll raise it by $0. Now the only thing I can't do, if I pay by 0.
Guess what?
Ooh, hold on. That keeps going to the left. So another really good thing to point out, lines don't stop. Well, I don't know why you haven't gotten there when you're talking to me. So when we go to graph y equals 3x, its origin is right here. It goes up by 3 over 1, up by 3 over 1. But that doesn't mean that my line only exists out here to the right. Stay on the ruler. So not only do I have to start at the origin and go up by 3 over by 1, but now I have to go down 3 over 1, down 3 over 1, down 3. Hey, look, they intersect. You should find a point down here where they intersect if your graph is big enough. So that's another good thing to point out. You only have one line so far that is concerning to me. So make sure that you know so when they talk about making a complete graph or a full graph, as like, so if you box in this as the view of your graph, if the line continues to that edge, you continue to that edge. That makes sense? Pretty soon, I got some people sitting there just waiting, which confuses me because you're in like the accelerated class and you should accelerate yourself. Pretty soon we'll talk about complete graphs. If I go to make C and I go up to 8, 1, 2, 3, 4, 5, 6, 7, 8, and I start taking that slope, -3 over 1, -3 over 1. This is part of my line. But if I only graph that part of it, and my whole graph space is everything that you see, that is not a complete graph. It is a partial graph. So, I love that you asked that question. A complete graph, by like our definitions, well, yes, we will utilize the arrows, but it fills the space we have. So if you imagine there's a box around your graph space that is like the 10 by 10 you're working with, or whatever you're dealing with. There is a box around your space. You want to continue that line to the edges of those box or that box. So I would continue it all the way down to here where it meets the edge of that box. Then I can stop. Right, so whatever space you're dealing with, and you might just go ahead and sketch a quick little box around your graph space. No, I have not always told you that.
By that I mean
Because I would say, like, look at your resources and think practically. What is the slope of D? There's no number there. What's the slope? 1, because we have 1x. So D, the slope is 1. Take a minute or a couple, finish up your graphs. I will put mine up in just a minute so you can check. If you're talking, your graph should be done, and when I come around, I should be able to check them. You can just extend it. Yeah, just like lay a ruler on it and extend your line out to the edges if you want.
I did something wrong.
Your graph should look something like this. And then I have a label way at the bottom. You can't quite see it though. This line is y equals 4x plus 3. Please make sure that you have labels next to those lines so you can go back and look at, oh yeah, that has a slope of -3. That has a slope of 1. And then we can use a rule if you want to make our life easier, just to connect the points. Hey, please make sure that you've connected the points to make lines. I've lost my rule. Hey, quit following me around. I know you want my attention. I'll come to you in just a moment. Sit down. Does that make sense? Then label that y equals 4x plus 3. Is it a question?
Yeah.
What's your question?
Did you say you had to do it on that?
No. That's not a pertinent question.
I was proven there. Why do we just keep doing linear equations?
Because we're not ready for anything else yet. You have my absolute permission to extend your thinking or learning outside of class as much as you want. But until you can actually keep up with what I'm doing in class, I don't want to hear you off topic in class. Alright, so then what happens if we just have a description? So for A, B, and C here, and if you have space on your paper, you can go ahead and draw a new set of axes if you want. And if you have space, you can draw a new set of axes. I need you. We're moving on. We're doing something new.
Should we just go to the back?
Sure. I mean, it's up to you. These are your notes for you. Like, these are for your benefit. Now, when you can't do the stuff on the mastery, that tells me you probably didn't do what you were supposed to in class. So try to sketch graphs of these 3 situations. Don't overthink it, but discuss with the people around you. Yeah, you can put them all in the same X, Y. I would definitely not try to use the same one we had, though. You're graphing those 3 situations. Yeah, so they don't give us the equation now, they give us details about the situation. For example, oh, it got like held up.
Good afternoon, Alex Dale. Please come to the office. Alex Dale, please come to the office. Thank you.
Maybe again, and I say this with love, but I think I'm putting a tiny bit too much credit on you guys being able to like infer what I'm asking for. You have drawn a new XY axis if you followed my advice. We're trying to take the details given to us and figure out what that would look like when graphed on the XY axes. So, I put this window real small. The first situation says a pattern that has 3 tiles in figure 0. Okay. Actually, I'm going to turn this way. 3 tiles in figure 0. And adds 4 tiles in each new figure. Okay, well, actually, I'm going to make this taller because actually looking at these situations. So here's my 3. Adds 4. Okay, 1, 2, 3, 4, and I go over by 1. Add 4, 1, 2, 3, 4, and I go over by 1. If we want to label our axes, Y is the figure number. Sorry, no, X is the figure number. Waiting to see if anybody caught that. Y is the amount of tiles. Our output is tiles. X is our figure number. So if we want to label our axes. Now, realistically speaking, we couldn't have any more or any less than 0 tiles, but we're not just speaking realistically, we're speaking mathematically.
Isn't that math isn't real?
Saying that math will let us model situations that could not happen in the realistic world. So, yes. It has 2 tiles in all figures.
Oh, I get it.
Then, next to your graph line, see if you can write the equation that matches it. Anyone know the rule for A? Charlie?
It's
4x plus 3? Absolutely. Pattern that shrinks by 3 tiles between figures and starts with 5.
That's a boring line. Not that one. C. C is a boring line.
Anyone know the equation for B?
Can I say it?
Yeah.
Negative 3x plus 5.
Negative 3x plus 5. Good. Then C. Bear, why are you back there complaining that it's a boring line?
Because it just goes, it stays at 2. It's just a straight, flat, horizontal line. It's stupid.
Straight, flat, horizontal. Because the y-axis is our tiles, the y needs to be 2. Boom. And it stays 2.
It's basically y equals 2.
So what you're saying there is it's like y equals, what's our growth? 0x plus 2. So you are correct. That line would just be y equals 2. Now what do you think a vertical line would be? Henry?
X equals 2.
Yeah, x equals whatever it is. So vertical lines are x equals. Horizontal lines are y equals. And with that, that's all we got today. Have a wonderful day. Please do not lose your white homework paper. Please.